The Great Barrier Reef, a global icon, World Heritage Area, and sea country home for the first Australians. More than 70 traditional owner groups whose connections to the marine environment date back more than 60,000 years. Like coral reefs around the world, the Great Barrier Reef is under threat from climate change, which is increasing the risk to corals and other marine life from extreme weather events, particularly marine heat waves. This can result in a phenomenon called coral bleaching. But what does this mean exactly? Well, when water is too warm for too long, corals become stressed. A sign of that stress is bleaching. This means the coral is in trouble and losing the algae it depends on. Corals may glow a fluorescent hue or turn completely white. If heat stress is moderate or doesn't last long, it can cause bleaching, but most coral can recover. When heat stress lasts longer, or temperatures are extremely high, bleached corals can die, which can severely impact the ecosystem. As climate change warms the oceans, bleaching events are happening more and more frequently, affecting the health of coral reef ecosystems. Monitoring the health of the reef is important to understand how the reef is changing. But how do we track the health of the world's largest coral reef? Well, it all starts thousands of kilometers away, in space. The Great Barrier Reef is home to 16,000 species of plants and animals. From up here, you can see all 3,800 reefs along 2,300 kilometers of coast. Monitoring starts with temperature sensors, which help determine if any parts of the reef have been exposed to above average sea surface temperatures for a period of time. Exposure levels help us understand which areas are undergoing heat stress. If there is a high risk of bleaching, we alert our partners and ask them to report back any observations to us. If bleaching has been observed in many areas, the next step is to measure how prevalent that is across the whole reef, which means we need to get a lot closer.
And look at individual reefs. Aerial surveys using low and slow-flying aircraft are key in determining how much and where bleaching is happening. Trained scientific observers fly across all sections of the marine park, recording any visible bleaching. Shallow water coral that is stark white or fluorescent is clearly visible from the air at this height.
We sit on opposite sides of the plane, so we can survey both the reef crest and the shallow reef slope at the same time. At many different sites across a given reef, we record the prevalence of any visible coral bleaching. Hundreds of individual reefs are assessed this way, across an area the size of Italy. It's important that both high and low heat stress areas are surveyed, because coral bleaching is rarely uniform, and it varies from reef to reef, even between sites on the same reef. Aerial surveys give us a rapid overview of coral bleaching, but this is just one tool we use during a bleaching event. They can't give us the full picture. For that, we need to get closer still and look at individual coral colonies.
Down on the reef, several in-water survey techniques are used to measure the prevalence and severity of bleaching. Trained observers can survey large areas quickly while being towed on a manta board, or dive deeper to conduct more detailed surveys at specific sites. And to complement diver surveys, we're developing amazing technologies like remotely operated drones. Detailed assessments can take several months, but are essential to better understand the potential impact of a bleaching event. Mass coral bleaching events can result in the loss of coral habitat, fish, and other marine life. This, in turn, has impacts on the communities that depend on a healthy reef. Information on exposure, extent, prevalence, and bleaching severity gives us a full understanding of how the reef responds to heat stress, including how that response varies across the ecosystem.
This helps us better understand the impacts of climate change and the reef's resilience, communicate the facts, and make evidence-based management decisions on which parts of the reef may need greater protection. The Great Barrier Reef is big, vibrant, and beautiful. Its astounding biodiversity is one of a kind. We all have a role to play in its protection by working together to take strong action on climate change. Visit our website to learn more about actions you can take today that will protect the reef for generations to come.